and welcome back to another Fusion 360 tutorial based on the Titans of CNC building blocks. In this tutorial we're going to work on the Titan 4M as shown on your screen right now. Well, let's begin. So in this tutorial we're going to be playing around with some different settings and different ways to draw things that is a bit unfamiliar to you right now, but hopefully by the end it'll be a bit more normal feeling. On this first sheet here, we don't have a lot that's different. We have a triangle this time. It has a thickness of 0.75 like all the rest, and we get our dimensions. The difference here is that when we start, the origin is going to be in the center bottom of the triangle, and then we need to make our angles and lengths and dimension them based on that location. You'll also notice that the center line that goes down the middle of the triangle is dashed, with a long dash, then a short dash, and a long dash. And this is often customary for a part that could be mirrored, that meaning that we can draw one side and then flip it or mirror it over to the other side, which is how we're going to create it. So let's begin with that. So as customary, let's start by saving our work. To enable autosave, navigate to your class, your folder, and the Titans building block folder and create your file. Save it as Titan 4M. Once the blue spinning wheel goes away, we can close up our data panel and begin with a sketch. Place the sketch on the top surface, and first of all, let's rename that sketch to keep ourselves organized, and we'll just call that basic shape. And enter. Now we need to create our triangle. So as I said before, we're going to create our mirror line, and we'll give that the dimension of 2 and the angle of 90. Enter. And we're going to select it and hit X. That's going to create and turn it into a construction line, which will help us with the extrusion later. Now I need to create our 2 angled lines, or I should say we're going to create one and then mirror it. So L for line, drag a line out, hit the check mark, D for dimension, and we're going to dimension the length from the origin, 1.150. Now we can do a horizontal vertical constraint and just put it right there. Now it's time to mirror it. So we're going to go up and we're going to click on mirror. It asks us for our object first, so we want to mirror that. It asks us to select the mirror line, which is our construction line, and there we go, perfect copy. Hit OK, and then we'll just finish it off by drawing a line along the bottom. So there's our triangle. We'll now finish sketch, and we'll extrude it, and you'll notice that when we click on extrude and then click the shape, it selects the whole shape, and that's because of that construction line. If it was a solid line, you'd have to select 2 separate triangles. So extrude it to 0.75, and then we're going to put our fillets in all 3 corners. 0.05, and then hit OK, and that is the end of sheet 1. Let's move on to sheet 2. Alright, so for sheet 2 we need to place 3 threaded holes. So being a triangle, it's not going to be very much different than we did other holes. We're going to place them, we're going to position them with dimensions, and then we're going to program the thread in. So when we look at our drawing, we can see that we have our dimensions for our locations and of the holes, and we also have some information on the thread. We can see that it says 3 times the diameter, 0.211 for chamfer, so we know we're going to need to use the countersink tool when we do the threads. And we know that our holes are going to be 10/32, and they need to have a minimum depth of 0.375. So they're not a through depth, so we have to stop somewhere. So we'll just do 0.5 as customary to give us a little bit of clearance for the tap if this part was made. So let's begin. Alright, so here we are on sheet 2. We're going to put in our holes, create a sketch, rename it holes. Nothing new here. Hit enter. Now we're going to create points, and we're going to place our 3 points roughly where we want them to be, and then we'll dimension them out after. D for dimension, or click up on the command bar, and select our first point and the origin. That's going to have a dimension of 0.828. We'll do the same for the other side because it is identical. Click there, type in 0.828, enter, and then we'll need to set the height of that point. Click, and 0.189. And then we need to set the height of the last point, and it is 1.637. And now we'll grab the horizontal vertical constraint command, and we'll go and set the rest. Click, click, boom, and click our origin, click our top, and now they're all aligned horizontally and vertically. Finish sketch. We'll create holes. Don't worry if they show up all weird, we'll fix them in a second. So we'll go to the hole command in the command bar, and we'll select our 3 points. 1, 2, 3. We need to make sure that we have hole type as chamfer, that it's tapped all the way through, and we're going to put in a depth of 0.5. We are going to put our chamfer in at 0.211. We are going to select number 10 threads, and we're going to select the 10/32 thread pitch. Class 2B modeled, everything's good, hit OK. And that is the end of sheet 2. So things are getting a little busy here on sheet 3, so we're going to tackle this in 2 steps. The first thing we're going to do is create the pocket in the center, and we're going to create the cuts on the 3 corners first, then we'll deal with the slots on the side. So let's begin. So on this part, we'll start by creating our sketch as always. Place it on the top, and we will begin by doing an offset. So we'll offset it by 0.174 from the edge. That'll create the rough shape of the pocket. And now we'll fillet the first corner and a radius of 0.189. We won't click enter, we'll click the other corners first, which will then use the same measurement, and hit enter. And now we have our center pocket made. We just have to finish the sketch, rename it pocket. Don't forget, keep it organized, finish sketch, and now we can extrude that pocket down, and it needs to go down a depth of 0.65. Hit enter, and there we go. We have the center pocket created, and we can move on to the next one. So for the recessed corners, we're going to do this a few different ways to show you how it's done. So we'll create our sketch, rename it, and we're going to look at 3 different ways to add circles. So the top circle says to get this step down, draw a 0.378 circle on center of the bolt hole and use it to cut the corner 0.375. So that's pretty straightforward. We just have to snap our circle to the center point and drag it out and give it a dimension of 0.375. That one's not too hard. The other ones, though, don't work for that because the dimensions aren't quite right and they won't be tangent, and the circle won't be centered on the corner. So we can't use the existing holes. So we need to draw 2 circles that are tangent. So the first way to do it is to just draw a circle and give it a dimension. We can hit equal and just assign the same value, as our existing hole. And then what we'll do is we'll click and drag, I'll hit escape, and drag that circle into our part roughly where we want it to be. Then we can use the tangent constraint to make the circle tangent to the sides. Click there, click there, click there, and click there, and you get the circle centered on the corner tangent. The other way to do it is just to create a circle tangent from the beginning and doing a 2 tangent circle. We can click on one edge, 2 edge, drag it out, assign it a value. Could use the equals constraint as well, but 0.378 is quick and easy as well. Enter. And there we go. 3 different ways to do the same thing. Finish sketch. And all we need to do is extrude them. We need to extrude it to a depth of 0.375, as it said for the top point. And then we are done with the recessed corners. And we can move on to the 3 slots on each side. So on your screen we've got the sheet 3 back up. And you can see that on the sides of the triangle are slots. And the slots are cut by just using a circle, extruding it into a solid, and then using it to delete the part we don't want, called cut. And all we need to do is know that the circle has a radius of 2 or a diameter of 4, and we have our 2 dimensions here, 2.222 and 1.949, that tell us how to locate that circle in reference to our part. After which we'll rotate it around using a circular pattern, which we've already done before, and then we'll be done. So let's have a look at how that's done in practice. Alright, so to start, what we need to do is create a sketch that will allow us to do our circles on. So we're going to select the lower recessed part there on the corner, because that's the same height this slot needs to be at. We're going to click circle. We're going to need a circle later for an axis, so we'll just place it there. Size doesn't matter. And then we need to create a circle with a radius of 2, so that would be a diameter of 4, since circles are drawn by diameter. Enter. Now we need to place our circles properly. So dimension, origin, center of circle, and that has a distance of 2.222. Enter. We'll do the same thing for the other direction now. Origin, point, drag it out, 1.949. Enter. And that'll position our circle exactly where it needs to be. We'll take care of that axis circle there, that one later we're going to use. Click on it, dimension it out, 0.667. And it's centered within the triangle, so we can use the horizontal vertical constraint to do that. Center point, origin, and we're done. Now we can create the slot. So we'll finish our sketch. We're going to extrude that circle, and it's going to become another body that we'll use to remove parts we don't want. So we got to click that. We're going to type in 0.125, and it automatically thinks it wants to cut. So we hit enter, and now we have that nice little slot there. Let's click on it down in the timeline, and let's create a pattern, a circular pattern. And we need that circle now that we drew in the center, so we'll turn our sketch on. We'll go to select axis, and then we're going to spin it around that circle. A 3 already comes up, so we can hit OK. And we have our slots. So now our drawing is complete. We'll just housekeep. We forgot to rename sketch 7 to slots, so we'll do that. We'll also turn that off, and we will go up to modify, and we'll chamfer this part, break all those sharp edges, and then it's done. So chamfer, We're going to click on the edges we want to chamfer, which is that one, and that one. 0.01 for a chamfer distance, and hit enter. And that's it. The part is done. And you've now completed Titan 4M. Save your work, hit OK, and move on to the next one. Thanks for watching.